hydrofluoric acid, which is commonly mistaken for a strong acid, is a weak acid, and the Ka for it is 6.3 times 10 to the negative fourth. We want to find the pH of a solution of 0.5 molar HF. So what we're going to do is write out the dissociation of the acid, and you can use hydronium or hydrogen, it doesn't matter. And we're going to have an ice table. So ice table, I represents initial, C represents change, and E represents equilibrium. So we're going to start with our 0.5, and our goal is to find out how much of that hydrogen actually dissociated and is in solution, because that will tell us what the pH is. So we're going to subtract X and we're going to add it to both sides. And we're going to add it to the product side. So what we want to do is set that equal to our Ka expression, or input those into our Ka expression. So we've got H plus A minus products over our reactant, so the acid, and then we're going to input the values that we get at equilibrium. So again, I is the initial. We initially don't have any of the H plus or A minus, so we know that we're definitely going to go forward to the right, and then we're going to subtract X from the HF because that is going to dissociate, and we're going to add it to the other side, and then these values, when we add up the columns, are going to be our equilibrium values. So we're going to plug those in, and what we want to do is assume X is small, and we're going to set that equal to our Ka. So we're going to cross that out and do 6.3 times 10 to the negative 4. And then we're going to solve for X by cross multiplying. So we're going to do 0.5 times 6.3 times 10 to the negative 4. And when we multiply the 0.5 times the 6.3 times 10 to the negative 4, we get 3.15 times 10 to the negative 4, and that's going to be equal to X squared.